Hello, in this video we're going to talk about box plots. Box plots are a way to display position data. Alright, so we're going to display position data so that we can talk about things like spread, how far the spread is of the data. So the box plots deal with what we call quartiles. And we talked about quartiles in the last video. So quartiles are 25th percentile, 50th percentile, 75th percentile. Okay, so these percentiles excuse me, are what we call quartiles. Okay, this is the first quartile. Actually, this is the second, but we call that specifically the median. And then this is the third quartile. Now we found these in a previous example, so we're going to just use that previous example to graph or display this data. So we're going to go look back at our previous example that we did from the last video, and we have our quartiles listed here on this example. We figured them out. So we're also going to need the minimum and maximum because they're also graphed on the box plot. So it graphs 5 numbers, what they sometimes call the 5-number summary. The minimum, the first quartile, the median, the third quartile, and the maximum are all graphed on this box plot. Okay, the box is going to be in the middle 50%, so from 25% to 75%, that's going to be your box. They also call this box and whisker because there's 2 lines coming out from the end that represent the first and fourth quartile. Alright, so we have these values. We're going to use those now. 21, 23.85, 21.0, 23.85, 26.6, 29.5, 26.6, 26.6, 29.5, and 32.2, I believe, was the maximum. We'll just double check again. See if that was the maximum. I believe it was. Yeah, 32.2. Okay, so now we have those numbers. This is the minimum. This is quartile 1. This is the median, or quartile 2. This is quartile 3. This is the maximum, or the fourth quartile. Okay, so we have those numbers. Now what we want to do is we want to graph this and display the position. So in order to do that, we start with a number line. So we draw a line. Oops, let's make it nice here and correct. So we draw a line. Okay, and we want to make sure we have numbers on there that represent these. So I'm going to start out with 20 because that's lower than 21, and then we have to go up to 33. All right, so I might go by 2 here to make sure I have enough marks, or I might go by 3, I might go by 4, whatever you need to do so that you get to right around 33 when you're over here. Right, so let's go by 2s. 22, 24, 26, 28, 30. So we need to, basically, I'm going to need to spread these out a little even more because that's not enough spread there. So 22, 24, 26, 28, 30, and 32. And 34. So 24 and 22. Okay, so we have a number line that can be represented on this number. So the first one is going to be 20. So what I'm going to do is just graph these above here. So this is 21.0. It's halfway in between here, 21.0. I'm going to label it. 23.85. 23 would be halfway. 0.85 is a little more. Since it's not great accuracy here, I'm going to write the number above it so that I know that that dot represents that. 26.6, there's 27, it's less than that. So put the dot here. All these dots should be in a line across here. 26.6. 29.5, 29 is halfway, 0.5 would be 3/4 of the way, so 29.5. And the last number is 32.2, that'd be not 33, it'd be closer to 32. And we'd mark it there. Okay, now when we make the graph, this part and this part are just single lines. Okay, and then we put the box in the middle. So we put a box around this half. That's half of the data set. And then we can break it up into quarters by drawing another line through this one. So now we have the first quartile, second quartile, third quartile, and the fourth quartile. Now, those are pretty evenly spread. They don't look like they're too much difference. This one looks like it's got a little bit bigger spread here than any of the other ones, but they look pretty even. Spread, this one's the shortest spread. You can also subtract and see what they are, for example, but you can also use the graph. You're going to be looking at graphs and talking about spread on this. So the second quartile is going to range between 23.85 and 26.6. That's going to be our second quartile. That means 25% of the data is in this box between these two numbers. 25% of the data is here. 25% of the data is here. 25% of the data is here. But it could just be spread out more, and that's why the box gets bigger or smaller if it's spread out. All right, so you're going to need to know it, and if the first quartile and the minimum are the same value, you wouldn't even have a little line here. You'd be at the same value twice. That can happen here as well. Okay, it's less likely to happen in the median, but it could happen at the median, and the third quartile is the same. It just depends on if there's a lot of numbers that are the same right between these two values. If there's a lot of them that are exactly the same, then they could be the same line. Okay, so that's how you create it. That's what we're talking about spread. Let's take a look at some problems in the book and look at those specific to box plots. Okay, so here we go. So here's a survey. Okay, it says the following box plots were given. All right. China looks like it's all in one quartile. That means all the data lives in one quartile. Okay. This looks like the upper third quartile and the median are the same. And this one looks like there is no first quartile. The first quartile and the minimum are the same here. Right? Okay, and if they actually give you the number, 0 would be the minimum here. It says in the survey of 20-year-olds asked the foreign countries they visited in their lifetime. So how many foreign countries, right? Right. So what they're saying here is that all the data is from 0 to 5 here. There aren't any. They're all the same. They're all 5s, I believe. China probably would be all 5s. Or an even number of 0s and 5s. It has to be uniform there for that. But it has to only, it can't have middle numbers because then it would have a thing drawn there. You'd have a box in there. Okay. Let's look at some other ones here. So here the minimum is 0, the first quartile is 2, the median is 4, the third quartile is maybe 5.5, I don't know, 5, and then there's 6 here. So, and the minimum or maximum is 7 here. All right. We can't tell how much data is in this because it doesn't, it's just graphed by percentiles or by percentages, right? So we don't know that one has more data than the other. We just know how they're spread apart. This one has more middle data than this one because it's shrunk down. This one has more in the between 3 and 7 than this one would have between 3 and 7. Because 1 whole quarter is between 3 and 7. Most of the data there would be between 3 and 7 because you have a long line. Okay? Now outliers on this case. An outlier for a data set would be something that's extended out to the end. So 7 could be an outlier here. All right? Because it's way away from the middle of the data. So 7 could be an outlier. We do have a way to determine whether it's an outlier based upon the this interquartile range. So let me give the formula for that. Okay, so let's see. We're going to get back to the thing. So for an outlier, that's not what I want. Okay, outliers are 1.5 times the interquartile range, IQR, interquartile range, that's Q3 minus Q1 is how you determine IQR, interquartile range. So it's 1.5 times this away from Q1 or Q3. So it has to be higher than this value to be an outlier on the right hand side, and it's lower than this value away if it's outlier on the other side on the left. Okay, so if we look at this problem again, that's not it. We were looking at a problem here. Here it is. And we want to test this outlier here. So let's say we wanted to test that. So what we want to do here is we need to know IQR. So we need to know how wide this box is from here to here. That's the IQR. So let's say that's not 1 because 1's right about here in the center. So we're going to say that that's 1.25 about. And maybe this is 3/4. So let's say that this is 1.25. So we'll say that this is about 2 units wide. The IQR is 2 units wide. So if we take 1.5 times 2 units, we get 3. So that means any outlier is 3 away from the box. Or more than 3 away from the box. I'm sorry, more than 3. So if we're more than 3 units away, we would be an outlier. So looking at this side here, that's not 3 units. This line is not 3 units away. So that is not an outlier. But looking at this side and going this way, that is more than 3 units. Because 3 units supposedly is 4 right here, right? 4 to 7 is 3. So this is more than that away, so that means 7 is an outlier by this definition. It's more than 1.5 times the IQR away from Q3, away from this edge of the box, or away from this edge of the box, going the other way.